Okay, right. Good evening, all. What about my audio? Am I audible? Good evening, all. What about my audio? Okay, audible, right? Right. Okay. So good evening again. Yeah, we'll start. We'll start. Seems yeah, some of the students are still joining in, but now it's 7 minutes past 6 minutes past 7. So we'll start. Right. So this is the ninth week ongoing before the exam, and this is Saturday as usual. So we are meeting every Saturday. No? So this is Saturday as usual. So which means the week is already finished. Week is already over. Right? You have exactly 8 weeks before the exam. Right? Exactly 8 weeks before the exam. Right? Okay. So don't waste even a single minute of the time you have. Right? 8 weeks means that is just nothing. Right? And it flies. Right? So therefore, don't waste even a single minute you have. Right? If you have a minute, a spare minute, do MCQ. If you have a spare 2 minutes, do MCQ at least. Right? So therefore, don't try to waste because now these 2 weeks will decide your entire life. That's the thing. Sorry, 8 weeks will decide your entire life, not 2 weeks. These 8 weeks will decide your entire life. Right? That's the thing. Now, otherwise, if you didn't go to the expected result, if you didn't get the expected result by your first attempt, if you are a first attempt student, right, then the only option it's available will be the second attempt, and it takes another whole year to do it. So, which means your whole life is uh, whole life will be 1 year delayed, 1 year behind to what you have planned, right? So, therefore, now worst case scenario we have second attempt as an option, but don't try to rely on that. Don't try to rely on that. If you are a revision student, then you are already in your second or third attempts, right? So therefore, your time is highly critical, right? Highly critical. Okay. So therefore, my point is don't waste even a single minute, a single second uh, in the time remaining now, right? That is exactly 8 weeks, right? 8 weeks means now we'll be meeting like 7 more days before the exam, right? Up to the exam, up to 10th of November, we have just 8 weeks, right? So before the exam, we'll be probably meeting 7 days, 7 more days, right? So it's like now, if we can have the class on all 7 days of the week, just by a week, the class is going to be over, right? For your other classes also, that's the same thing. Huh? That's the same thing. Let's say you are attending to a theory class or a revision class, right? Now that class will be occurring another 7 days only. Another 7 days only. So if we can have the class on all 7 days of the week by next week, whole syllabus. So all the thing is finished, right? So that is how it is. That is how critical that is, right? So let's go to the discussion. I hope you have tried the paper already as a timed paper. Yes. Anyone who has anyone who hasn't got the paper? Because I opened the discussion today to everyone, and yeah, for the registered students, I know you have got the paper already, and for the other students who are joined just today, if there's anyone who didn't get the paper, let me know. Sorry, you didn't get. Okay. Give me 1 second. Only one, right? Okay. Right. Listen, and the other thing is now when you study these days, when you study on daily basis, you might come across doubts, questions about the subjects. Like now, let's say physics. Let's take physics, right? Sometimes it may be something about the questions we discussed today, or maybe something other than something outside of what we are discussing in the class, right? So likewise, you will get subject matters now. What I want to say is for subject matters, feel free to use our paper class group, because now in that paper class group, all of you are writing papers and all of you are there with a common goal to sit for the exam in 2025, right? After 8 weeks of time. So therefore, now if you get questions, if you get any doubts, now what you can do is you can use that group as a platform to discuss them out, right? So even if I saw the message, I also can reply. And now if I didn't see also, if there's anyone who know the answer for the particular question someone asked, you can answer out, because if someone is getting an advantage, if someone is getting something out of what you deliver, which means both of you will go together. I mean, both of you will go through the exam as a whole, as a batch, right? So therefore, feel free to use that group for any subject related matters. That is totally fine. That is totally fine. So if there is something to be asked from me also, I don't mind whether you ask that in the group, right? And what I need to say is, anyone in the group can reply, respond those messages if there is something you already know, right? Now even in the Zoom chat also, if someone missed something and if that person has asked, let's say a point is missed, when I give you something, someone has missed the point. Then if that particular person has asked about the point in the chat, if you see that that person is seeking that point, right? So you can respond it. That's totally fine. No? That's totally fine. Any questions? So are you going to start a paper class to 26 batch students after 25 A levels? Yeah. Probably in November or December. Probably in December, I have planned to start. Right, in December. Sometimes it may be in November. Most probably it will be in December. December will start, right? Right? Okay. So what I need to say is, and what I need to encourage you to do is work as a group, work as a batch, right? Work as a batch, right? This is not an individual competition, right? So don't keep individual competitions. Work as a batch. Then as a whole, as a batch, you all will go through, right? That is how it should be. All right. Connect with that. Komari, ammondo, right? So therefore, help everyone, help each other, each other, and share your knowledge with each other, and go through the exam as a batch. That's a better approach, right? Let's go. Let's go to the discussion. First one, the SI unit that is used to measure the dose of radiation of absorption energy per unit mass is. About radiation absorption energy, we met this thing in one of the essay paper questions before as well. I think in paper 2 or paper 3, you met that, right? Energy absorption, energy of radiation absorption is measured by sieverts. Sieverts, that's a theory part. Sieverts, SV, sieverts. So for the first one, answer is 3. For the first one, answer 3. Sieverts. Becquerel is the, listen, first unit is Becquerel. Becquerel is the standard unit of radioactivity. Becquerel is the standard unit of radioactivity. And Geiger is a unit to measure radiation. Radiation is measured by Geiger. Sieverts is here radiation absorption energy, and decibels, you know, intensity level, joules, energy. Second one, question 2. In a measuring equipment that applies the Vernier principle, 49 parts of half millimeter each in the main scale, capital M are divided into 50 parts in the Vernier scale V. The diagram shows how the scales are placed in course of measurement made with the instrument. Assuming that there is no zero error in the instrument, the value of that measurement is. Okay. So, two important things. This main scale is in half millimeter divisions, because that says it's calibrated in half millimeter divisions. So that is in half millimeter divisions, right? And so with that, least count will be different. First, I'm going to find the least count. See, least count of the instrument is 1 division of main scale, half. 1 division of main scale over number of vernier divisions. So least count of the scale is 0.01 millimeters. 0.01 millimeters. So we know any reading that is given by a vernier instrument is given as reading of main scale plus reading of vernier scale. Reading of main scale plus reading of vernier scale. And reading of main scale is completed main scale before vernier 0. Right? Reading of main scale is completed main scale before vernier 0. Count the divisions. Now 3 centimeters means 30 millimeters, no? 30, 30.5, 31, 31.5, 32. 32 are completed. 32 millimeters. Plus vernier scale is read as number of coincided divisions times least count. Number of coincided divisions times least count. Number of coincided divisions 1, 2, 3, 4, 5, 6. Ne? 6. And 6 times least count 0.01. Simplify this thing. R equals 32.06 millimeters. 32.06, answer 2. For 2, answer 2. 3. Given that the Planck constant is h and the velocity of light is c, the energy E of a photon of wavelength lambda is. Energy of a photon is given by E equals hf. Very straightforward. Energy of a photon is given by E equals hf. E equals hf. So, but we know F can be written as C over lambda. F is C over lambda because C equals F lambda, right? This is coming from V equals F lambda. Listen, this is coming from V equals F lambda. V equals F lambda. So therefore, for photons, when they travel with velocity of light, C equals F lambda. So therefore, F is C over lambda. F is C over lambda. Then E is HC over lambda. E is HC over lambda. Answer 5. Next. Next, the graph that shows the variation between absolute temperature T and resistivity rho of a superconductor. So in current electricity, we draw 4 variations of resistance and resistivity with temperature, right? For conductors, semiconductors, insulators, superconductors, right? You have to know all 4 graphs. For a superconductor, that is 3. For a superconductor, that is 3. And then the gun graph මතක තියෙන්න ඕනේ. Graph එක මතක තියෙන්න ඕනේ. මම ඊතුරු graphs එක මොනවද කියලා කියනවා. In 1, that is the variation of a conductor. Right? Diagram 1, graph 1 is variation of a conductor. Diagram 2 is semiconductor. 3 superconductor. 4 and 5 are false graphs, false diagrams. 5. Three paths named A, B, and C of 3 particles which are moving in a magnetic field are shown below. The corresponding particles to these 3 paths would be, right, magnetic fields. These actually from forces on charges in magnetic fields. Forces on charges. Let's see. Field is cross. That is a cross field. Right? And 3 charges are given: A, B, and C. Right. The theory is this. Listen. The theory is this. Force acts on a charge in a magnetic field is given by Fleming's left-hand rule. That is given by Fleming's left-hand rule. When this shows direction of current, this direction of magnetic field, right? Index finger is direction of magnetic field, and thumb gives us direction of force. Thumb gives us direction of force, right? Current, magnetic field, force. When it comes to charges, the direction of current is like this. Direction of current is like this. For a positive charge, direction of current and direction of velocity are same. Direction of current and direction of velocity are same. But for a negative charge, direction of velocity and direction of current are opposite. Right? This we have to know. Now, an example is electron. For the direction of motion of electron, current flow is opposite because there is a negative charge. Right? That is an example. So likewise, this has to be known. Okay, now I'm going to determine the direction of current on each of those. Look at here. This is how this is applied. Now for the first one, A, this is very straightforward. There is no deviation. If there is no deviation, which means there is no force due to magnetic field. If there is no force due to magnetic field, that is because there is no charge. Because force on a charge in a magnetic field is given by F equals dQE. Right? Force on a charge in a magnetic field is given by F equals dQE. So no charge, then this has to be gamma. No charge, that has to be gamma. Right? Gamma rays are there? Yes, that has to be gamma. Neutrons are also there. That is gamma or neutron. This is gamma or neutron. The idea is that is something it doesn't have a charge. Something that doesn't have a charge. That's the idea. Right? And here, now if this travels this way, force on C has to be, look at the board, force on C has to be upwards. Force on C has to be upwards. Now to satisfy that force, if I apply this theory, see, magnetic field is cross. Now the force is upwards. If the force is upwards, direction of current has to be rightwards. The particle is also moving to the rightward direction. Then direction of current has to be rightwards while the particle is moving to the rightward direction. See, then it has to be a positive charge because direction of current and direction of velocity are same. This has to be a positive charge. One thing is these are positive charge. These are positive charge. These are positive charge. And if you apply here, direction of force on this kind of a charge is downwards. Right? See? Now, field is cross, force is downwards. Can you see? Field is cross, force is downwards. So, direction of current is leftwards. Direction of current is leftwards. Direction of current is leftwards, which means there is opposite to direction of motion. This is a negative charge. This is a negative charge. Right? Okay. Now we can choose among the given answers. A has to be a neutral one. Then it's a neutron. And B has to be a negative one. Then electron. And 3 has to be a positive one. Proton. 3. Answer 3. Right? For 5, answer 3. Alright. Take it down if there's anything. Okay. Right. Next one. 6. The output F is logic 1 in the following circuit diagram. The inputs A, B, and C would be. Right. First, write the output using ABC. That's the way that you should do this kind of a question, this type of a question. Now, this circuit is given A, B, C, and F. Okay, like this. See, now start from here and simplify this. This is how to simplify. They are AND gates. Function of AND gate is dot. So therefore, now from here A comes into this gate, from here B comes into this gate. So which means this output is A dot B. The A dot B comes up to here. And B comes up to here, C is here, and this is B dot C. B dot C comes up to this point. And this is also an AND gate. So F is A dot B dot B dot C. A dot B dot B dot C. So if we simplify this, this is A dot B dot B dot C. B dot B is B. So if is A dot B dot C. This is the final output. A dot B dot C. Right? Dot function acts as multiplication in digital. Dot function acts as multiplication. Then if F to be 1, all ABC should be 1. If F to be 1, 1 dot 1 dot 1 is 1. Right? All ABC to be 1. So answer 5. For 6, answer 5. Next one. 7. If the sound intensity I of a point is increased by 100 times, the intensity level of that point will be increased by. Intensity level will be increased by. Right. So we know delta beta equations. Apply delta beta equation at once. 7. delta beta equals 10 log base 10 I1 over I2 intensity levels, right? Delta beta equals 10 log base 10 I1 over I2. Delta beta is asked, right? Intensity level will increase by, okay, delta beta is asked. Substitute these values, 10 log base 10. Now if initial value is I, final value is 100 I, increase by 100 times, I to I cancels. So delta beta equals 10 log base 10, 100. This can be written as 10 log base 10, 10 to the power 2. So we know by using logs, we can take this power to the front, this 2 to the front. You can take this 2 here. Then it becomes delta beta equals 10 times 2 log base 10, 10. This is 1 in logs. So delta beta equals 20 decibels. For 7, answer 2. Eight. Next. 8. A 2.5 meter long conductor moves perpendicularly to a magnetic field of a magnetic flux density 0.6 Tesla with a velocity of 6 ms minus 1. The electromotive force induced in the conductor is, that's a direct equation. That's a direct equation we have for the induced EMF in a linear conductor. 8. The equation is this. You have to know the equation. E equals BLV. E equals BLV, where B is magnetic flux density, or we call magnetic field intensity, and L length of conductor, V speed or velocity of conductor, E is induced EMF. Now B is given as 0.6, L is 2.5, and V 6. Simplify this. 6 times 6 क्या है 36 क्या है 36 times 25. 36 times 25 क्या है 36 times 25 क्या है 9 900. 36 times 25 is 900. So 9. So 1 for it 1 9. A velocity time graph for an elevator which moves upwards is shown in the figure. VT graph is given, right? A load is on a top loading balance inside the elevator. The best graph that represents the variation of balance reading X with time. Okay. First thing you have to know is, now that's a pan balance. If there is a pan balance, reading of a pan balance is reaction on pan. So therefore, now the system is like this. The system is like this. Now inside the elevator, this kind of a balance is there. A pan balance is there, and on that there's a person. On the balance there's a person. A load, no, not a person. A load is a load. There's a load on the balance like this. This is a load on the balance, right? Then we know there will be a mg, weight of the load, and there is a reaction that acts on the load by pan. And according to Newton's third law, this reaction is same on the object and the pan. No? So therefore, marking 1R is enough because that's same. That's same. Okay, now first idea is from 0 to first section of the VD graph, there is an acceleration. There is an upward acceleration there. Right? So first part is upward acceleration. See? First part is upwards acceleration. Now, if you need to check this out, apply F equals ma and you can easily check it out. That's a safe way. See? Now, first idea is this. reading of a balance, reading of a pan balance is reading of a pan balance is reaction on pan. Is reaction on pan. Right. Now this is for the first section. Look at the board. For the first section, upwards, F equals MA. F is R minus mg. So let's say the first reading has R1. Then there are three different readings. Sections sections readings. So I'll label them as R1, R2 and R3 accordingly. R1 minus mg equals MA. Right? Then here R1 equals MA plus mg. R1 equals MA plus mg. So which means this is a value which is greater than mg. Right? That idea we have. That is a value greater than mg. And second section is a uniform velocity. In uniform velocity, we know acceleration is 0. So second section, this is the second section. No? In second section, if you try to use the same, now A becomes 0 in the second section. A becomes 0 because that's a uniform velocity. Let's say that is R2, then R2 minus mg equals 0, R2 equals mg. So second reading is equivalent to mg. Second reading is equivalent to mg. Next reading, now that elevator decelerates in the upward direction. See, now next part is decelerating in upward direction, minus A. Decelerating in upward direction. Then again you can use F equals MA upwards. F is, let's say, R3 minus mg equals, this is minus MA. Minus MA. So R3 is mg minus MA. R3 is mg minus MA. R3 is mg minus MA. Right. Now we can compare these values very easily. And now the magnitudes of acceleration and deceleration are different. Magnitude of acceleration and deceleration are different, no? And you know, if there is a VD graph, acceleration or deceleration is given by gradient of graph. Higher gradient means higher acceleration. Now, higher gradient is a higher slope. Higher slope is in the third section. That's the higher slope. Higher slope is in the third section. So, therefore, there is a higher deceleration. Higher deceleration means the value here, this value here, MA, this value here is greater than the value here. Right? So, therefore, from here, from mg, a higher value is going to be subtracted. A higher value is going to be subtracted. If a higher value is subtracted, the remaining value is lowest. The remaining value is lowest. Right? When the higher value is subtracted, remaining value is lowest. Right? So, therefore, with respect to mg, this MA is mg plus MA should be, the gap should be less than the gap between mg minus MA, because this value is a higher value. Then go to answers. Now there are two answers which matches our initial conditions, 1 and 2. 1 and 2. In answer 2, gaps are same. In answer 1, you can see there's a clear higher gap between the uniform velocity part and the third section. So answer is 1. 1. 10. The most probable point for the center of gravity of the AE bar shown below is. For that, there's a theory we discussed in center of gravity. Right? Now, two tensions are given, no? Two strings are given, which means two tensions are given. This is how it should be done. See? Now, with the rod, two strings are given like this. Two strings are given like this at the ends. Two strings are given like this. This is called the equilibrium of objects under three non-parallel forces. This is called equilibrium of objects under three non-parallel forces. Right? Now already two forces are given. Why? Because tensions are known. Here we have a tension, let's say T1. Here we have a tension, let's say T2. Now if you extend these two, at some point they are intersected each other. At some point they are intersected. Now the third point in this system is going to be none other than mg. Only force remaining here is mg. There is mg. So according to the theory of three non-parallel forces, all three forces should intersect at the same point. But we know mg is always vertical downwards. So therefore, for sure we can say mg should go like this. Mg should go like this. Then the closest point is going to be center of gravity. Now in this case, that is D. You can draw this and check out. Paper. Once you have the paper, don't try to copy it down, because when you try to copy it down, the angles and the scales might be different. Right? So therefore, on the given paper itself, use a ruler and a pen or a pencil and draw it. Now you can draw it and check out. Answer is D. This is called equilibrium of forces under three non-parallel forces. Equilibrium of objects under three non-parallel forces. Right? For 10, answer 4. Understood? You can ask if there's anything. Right? Can ask if there's anything. Right. Next. 11. 11. If a particle with mass m and a charge q accelerates under potential difference of v, the de Broglie wavelength is de Broglie wavelength. Equation of de Broglie wavelength is, you have to know these equations. Lambda equals h over mu. Lambda equals h over mu. De Broglie wavelength, where h is Planck's constant, m is mass, u speed or velocity. Now the potential differences are given now. To connect speed with potential difference, we have to use an equation from electric fields. Right? For any moving charge, we know we can apply W equals Q delta V. For any moving charge, we can use W equals Q delta V, where W represents kinetic energy. Half mu squared equals Q delta V. Potential difference is now given as V. Potential difference is given as V. Subject U from this. So U is 2QV. Is it E? Q, ne? 2QV. 2QV of M. Square root. 2QV of M. And now plug that in equation 1. Plug that in equation 1. And simplify. From 1, lambda equals h over mu. And now u is 2QV over M. These are root term. So these are root term, which means this root term to this M cancels and it becomes a root term. Right? So lambda equals, simplify this, h over 2MQV root 2MQV 1 ne? 11, answer 1. Well, 12. A current I flows in an infinitely long conducting wire. If the magnetic flux density of the point at a distance r from the wire is B, the best graph that represents the variation of magnetic flux density B with 1 over is, right. So you have to know these equations. 12. Magnetic flux density at a point which is located r distance away is given by B equals mu naught over 4 phi 2I over 2I over, right. Now you know graph plotting. Use your graphing knowledge. B with 1 over. Create B and 1 over and check the shape. See, B equals mu naught over 4 phi is a constant. This is a constant anyway. So mu naught over 4 phi, this is a constant value, right? Times 2I 1 over. Very easy. See, how easy that is? 1 over is at x, and whatever it is as a product with the independent variable is gradient, and this is y. So shape is y equals mx. Y equals mx 2. For 12, answer 2. Thirteen. Ask if you have any questions, if you need any clarifications, right? So I'm continuing the discussion. But if you have any questions, I'm happy to answer, right? And as I told you before, if when someone asks a question in the main chat, if you use the main chat, everybody can see the message, right? So if someone other than me know the answer, feel free to give that answer. That is fine, no? That is totally fine with me. Right. 13. 13. 13 is a tricky question. Look at here. Theta. P. Right. So for this, the backup is backup in the sense the knowledge or the backup you have to have is the normal variation we draw in theories about the applied force and friction force. What is the normal variation we draw? The normal variation we draw is this. Friction force with applied force is this, right? So you better have that idea. You have to have, actually, not you better have, you have to have. You have to have that idea first, right? Okay, now let's see what happens here. In the increasing force, we applied parallel to the inclined plane of the object kept on the rough plane is, right. Now there are three main sections of this motion of the object. Look at here. Now initially we know anyway these weight acts, this weight acts, which means downwards the plane mg sin theta acts, right, and perpendicular to plane mg cos theta acts, right. Now if P is increasing from 0, there's a section where mg sin theta is greater than P, no? Right? There's a section where first section is when mg sin theta is greater than P. When mg sin theta is greater than P, direction of moving tendency is downwards. So therefore, friction will be upwards. Let's say F1, that is upwards. Friction will be upwards. So in this region, friction acts upwards, right? And if P keep increasing, at some point, P will be equal to the value of mg sin theta. That's normal. At some point, P will be equal to the value of mg sin theta, right? So second scenario, when mg sin theta equals P. When mg sin theta equals P, total downward force equals total upward force, which means there is no unbalanced force. If there is no unbalanced force, there is no moving tendency, there is no friction. So therefore, in this region, F becomes 0. This is not a region actually, this is a point. At this point, F becomes 0. And then what happens is, as the third, what happens is when mg sine theta is exceeded by P, which means when P is greater than mg sine theta. If P is keep increasing, that happens. Now, according to the object, upward force is higher. Upward force is higher compared to the downward force. Since the upward force is higher, moving tendency becomes upwards. So friction will be opposite downwards. Friction will be opposite downwards. So the second friction is going to be downwards F2 like this. So this is going to be downwards F2. And when this increases, after the third section, after the third instance, when that increases, at some point it will reach the dynamic friction and then keep moving with a constant friction, because we know dynamic frictions are constant, right? Now there's only one point you need to check. See, there are two directions for friction here. Direction of friction changes. Initially upwards, becoming 0, then downwards, right? So if the direction of friction changes, friction is a vector. So if that's a graph on a vector, it should be shown as plus and minus. So only answer given is 5. Only answer is 5. Right? So initially it is upwards, and when the P increases, it decreases and becomes 0. And then again the direction changes. So that is at the positive side. And when P increases, friction increases up to limiting friction, and then moving as a dynamic friction. Answer 5. So 13, answer 5. This is what we need to understand. That's a tricky part, tricky question. Right? That you need to understand. Right? Next. 14. Consider the following statements about the use of thermometers. A. 14. A. Mercury in glass thermometer is suitable to obtain the cooling curve of a liquid paraffin instead of thermistor. Correct. Thermistor is to measure temperature across or between 2 points. Right? එයාගේ terminals දෙකක් තියෙනවා. thermistor එකේ terminals දෙකක් තියෙනවා. ඒ terminals දෙක තමයි අපි connect කරන්න ඕනේ. Right? There are two terminals for thermistor, and those two terminals should be connected when measuring a temperature using a thermistor. And about the mercury in glass thermometer, in mercury in glass thermometers we have a bulb. We have a bulb like this, right? And if that bulb is covered with the substance to be measured the temperature, it gives us the temperature. Now since there is a liquid, it can be dipped in the liquid. It can be dipped inside the liquid, so it's covered properly. It's correct, right? So therefore, when it comes to mercury in glass thermometers, they cannot be used to measure temperatures in plane surfaces where it cannot be covered, right? Now that's the exact reason why now when you use a mercury in glass thermometer to check fever or something, that is why you need to keep that here in the armpit to cover it properly. Now otherwise, if you keep it to the surface like this, it is not going to give you a reading. Bulb එක cover වෙන්නේ නැහැ. හැම වෙලේම mercury in glass thermometer එකේ bulb එක cover වෙන්න ඕනේ. Bulb එක cover වුනේ නැත්නම් එයාට හරියට reading එකක් දෙන්න බෑ. Bulb එක cover වෙන්න ඕනේ. ඒතකොට දැන් උණ බලන්න කියලා මෙහෙම තිබ්බා කියලා බලන්න බෑ. මෙහෙම තිබ්බා කියලා බලන්න බෑ. හරි. ඒකයි අර මෙහෙම armpit එකේ තියාගෙන ඉන්නේ කියන්නේ. ඒතකොට cover වෙනවා. Right? So A is correct. B. Thermocouple is suitable to measure rapidly changing temperatures of a surface. Thermocouple, yes. Thermocouple is the best thermometer to measure rapidly changing temperatures and small temperatures. Small temperatures, rapidly changing temperatures. Thermocouple එක තමයි හරි. B is also correct. C. thermistor can be used to measure small variations of temperature in a gaseous medium. In a gaseous medium. In a gaseous medium. I told you, for the thermistor, there are two terminals. If these two terminals are connected only, it will measure the temperature across. If there's a gaseous medium, there are no 2 points to connect the thermistor. Right? Thermistor gaseous medium will use kind of bad. C is wrong. So only AB. Only AB means 3. For 14, answer 3. 15. Any questions? So in 13, why is the second one not taken as the answer? 13. 13. Second one के plus minus मारू है ना? में friction के direction का मारू है ना? Friction के direction का मारू ला दिए ने? Initially it was upwards, and after we exceeded the design, that is downwards. If direction changes, it should be plus and minus, right? And the curve එක කොහොමත් වෙන්නේ නැහැ. Curve එකේ angle එක වෙනස් කරොත් විතරයි. Now the angle remains same, only p changes, right? Curve එකක් එන්නේ angle එකක් වෙනස් කරොත් විතරයි. Next. Fifteen. 15 is a good calculation. Density of ice is x grams per cubic centimeter, right? And density of water is y grams per cubic centimeter. The volume difference when mass m grams of ice melts in cubic centimeters, right? So we know the theory part, respective theory parts, related theory part here is, we know when ice becomes water, when ice melts, it becomes water, no? When ice becomes water, density increases, volume decreases, right? Because our density of ice is 900, whereas density of water is 1000, right? But due to any state change, mass doesn't change, mass remains same, right? Okay, now densities are given. Densities are given. Since densities are given in grams per cubic centimeter, we will go with the same unit, because the final answer is also, it should be in terms of cubic centimeters. So therefore, I'm not going to convert any units now, right? So you all know that rho can be written as m over v. So which means m is given by v rho. Which means m is given by v rho, right? See, now we can apply this to ice and water separately. You can apply this to ice and water separately. See, mass of ice same, velocity, volume of ice into density of ice is x, vi into x. Now if vi is subjected, vi is m of x, no, m of x. Now you can do the same for water. Mass remains same, so mass volume of water times y. Now water volume here is m over y. Right. What's the question? Volume difference. What's the higher volume? That you need to know. Higher volume is in ice or water? Higher volume is in ice, right? I told you, when ice becomes water, density increases while volume decreases, right? So higher volume is ice. Then delta V is Vi minus Vw, m over x minus m over y. M is common, we can take it out, 1 over x minus 1 over y. A common denominator is applied. So m times common denominator here is xy. This is y minus x. 4, eh? 4. For 15, answer 4. Next. "16. A sphere of mass 2 kg is moving towards east with a velocity 4 ms minus 1. Now directions are given, so you better have the correct diagram with directions. 16. Right? To the east. To the east. Ne? East means mehe. To the east. मैंने මේ වගේ direction එකක් තමයි දීලා තියෙන්නේ. North, east, west. මෙහෙම යන්නේ. මේ තියෙන්නේ east එක. A sphere of mass 2 kg is moving towards east with the velocity 4 ms minus 1. Right. Something like this. And another sphere of 3 kg is moving towards north with a velocity 6 ms minus 1. The two spheres collide each other. Which means, now if they collide each other, this should be coming from this side. This is coming from this side towards north. Right? Collide වෙන්න පුළුවන් නේ. Right? 6 ms minus 1 3 kg ne? 6 ms minus 1 3 kg. Right? The two spheres collide each other, combine and move together after the collision. After the collision, they combine. They act as a combining object. They combine. The angle between east and the direction of motion is right. Now this is before the collision. This is before the collision, right? And after the collision, this is combined. Combined means this has to be 5 kg, right? 5 kg. If both magnitude and direction of a vector is unknown, mark it using two perpendicular vectors. That is how we do, right? Now both are unknown. Now I'm going to mark the velocities as y and x. I'm going to mark the velocities as y and x, right? Apply conservation of linear momentum. Apply linear momentum. That's a collision. That's a collision. First, I'll use linear momentum in rightward direction. In rightward direction. Initially, what it says is total initial. Total initial linear momentum equals total final linear momentum. Total initial linear momentum is 2 times 4. 2 times 4. This is vertical, so that is neglected. My considered direction is rightwards. This is a perpendicular direction. And here, 5 times y. Sorry, 5 times x. 5 times x. Right? So, 8 equals 5x. X equals 8 over 5. Having that in hand, now I'm going to use the same in a vertical direction. Use in a vertical direction. Then vertically upwards we have 3 times 6 initially plus 0. And finally 5 times y. Then 3 times 6 and 18. 18 equals 5y. Y equals 18 over 5. Y equals 18 over 5. Right? Okay. Now we know resultant direction is in between. Resultant direction is in between. Then resultant velocity has to be something in between like this. Right? So angle makes it east is the angle makes it x alpha. Tan alpha can be written as, see, tan alpha can be written as y over x. So tan alpha is y, 18 over 5 over x, 8 over 5. 5 to 5 cancels. 18 over 8, which means 9 over 4. 9 over 4. Tan inverse 9 over 4, answer 5. So 16, answer 5. Right, for 16, answer 5. That's a good question. So you have to do the calculation, right? Now, without doing the calculation, we can't say anything. Without doing the calculation, we can't say anything. How to do the calculation? 17. 17. Consider the statements about the atmosphere. A. Relative humidity of dry atmosphere will never be 100%. Correct. Why? In order to saturate a particular space, there should be water vapor available. Saturation is done with water vapor, right? If there is dry air, no water vapor, right? So A is wrong. A is correct. Relative humidity of dry atmosphere will never be 100%. Yes, because A, because uh, having water vapor is must. So that is correct. B. Absolute humidity increases whenever relative humidity of atmosphere decreases. No, opposite. As an example, when temperature decreases beyond dew point, RH remains constant while absolute humidity decreases, right? And when temperature increases, RH decreases while H can absolute humidity increases. So that is wrong, right? So it has an opposite behavior. Whenever, no, wrong, right? C. Relative humidity becomes 100% when the absolute humidity of the atmosphere is at its maximum value of temperature, maximum value at any temperature. Relative humidity becomes 100%. That is correct. Why? Now, the graph is like this. Whenever graph between RH and H with temperature, RH varies like this and becomes 100%, right? And H is like this. H is like this. H is like this. This is H. This is RH. And this is where the 100% is reached, which means that is the saturation. So relative humidity becomes 100% when the absolute humidity is at maximum. It is correct, no? Because after that point, absolute humidity starts to decrease. C is correct. A and C. Answer 4. Right? Take down if there's anything. 18. Alpha and beta particles are emitted by the decay of radioactive nucleus X Z A. If the dot element created is X Z A minus 4, the number of alpha and beta particles emitted respectively. Very easy. 18. X Z and A. Right? And it has become X Z and A minus 4. Right? Now, always when an unstable particle leaves a body, the respective nucleons. What are nucleons? Nucleons are neutrons and protons. The respective numbers of neutrons and protons are leaving the system. Right? Now, as an example, the theory part is this. The theory is this. Let me write here. The theory is this. Let's say we have an object A. x and y, right? If alpha leaves, now alpha has 4, 2. If alpha leaves, the dot element or the resultant element becomes x minus 4, y minus 2, like this. This is what happens. When an unstable particle leaves the system, the respective numbers of neutrons and protons are leaving the system, right? Okay. Then about the mass numbers, atomic numbers of alpha and beta, you have to know. Alpha and beta, you have to know, right? So these are the numbers. Alpha kiyanne 4, 2. Beta kiyanne 0, minus 1. Alpha kiyanne 4, 2, beta 0, minus 1. Now this is a good observation. Now in beta, mass number is 0. So therefore, beta can't change the mass number. Therefore, this minus 4 is only due to alpha, right? So if there is a to a minus 4, one alpha has left. If there is a to a minus 4, a to a minus 4, one alpha has left the system. One alpha has left the system. And when one alpha left, let me write down the reaction now. See, x, z and a, no? Now alpha left 4, 2. Then what's remaining is, this is a minus 4 and this is z minus 2. That's a different element now. Let's say y. Something like this. And now beta leaves. When beta leaves, since there is minus 1, minus means plus, ne? So it acts as plus. Then if 2 beta leaves, z minus 2 plus 2 becomes z again. So therefore, here 2 beta leaves, 0, minus 1. Then mass number is same, and in atomic number, z minus 2 minus 2, which means z. If there is z, there is a isotope again, there is the same element again. Since there is the same element, there is an isotope, right? So these are the numbers. Only 1 alpha and 2 beta. Only 1 alpha and 2 beta. 1, 2, 1, 2, 3. Ne? For 18, answer 3. These nuclear reaction questions are easier. They are easier. Don't miss those marks. They are easier marks to get. Right? Miss කරගන්න එපා මාර ලේසි මේ මැට ඇන්ඩ් එඩිෂන් කියලා කියන්නේ කොහොමද ලේසි පාඩමක්. හරිද? මැට ඇන්ඩ් එඩිෂන් කියන්නේ කොහොමද ලේසි පාඩමක්. ඒ හින්දා මැට ඇන්ඩ් එඩිෂන් වගේ එකක MCQs කොහොමත් මිස් කරගන්න එපා. ඊට පස්සේ එසේ එක මිස් කරගන්නත් එපා. ඉතින් එසේ එකත් ලකුණු ගන්න පුළුවන් හොඳ එසේ එකක්. Right? Lazy essay. It comes as 10B. 10A is thermal physics, whereas 10B is matter and radiation. Right? मैं क्लास के matter and radiation question ने discuss कराने एक पेपर एक essay का discuss कराने discuss कराने पेपर 3 के हरी पेपर 2 के हरी 3 के बेटा पेपर 3 के matter and radiation question ने discuss करा. Right? So as an overall, matter and radiation is an easy lesson, so don't try to miss it. Right? Next, 19. An egg is entered into a cylinder containing 400 milliliters of water carefully. Then the water level was raised up to 470 milliliters, which means volume of the egg is 70 milliliters. Volume of the egg is 70. First hint is that, right? So it is like this, ne? It goes in a cylinder, eh? Measuring cylinder, right? Now initially it was 400, and once the egg is entered, that was 470. That was 470, which means my first data is this. Volume of this egg is 70 milliliters. Volume of this egg is 70 milliliters. Then the water level was right. Now the seawater of relative density 1.2 is added into the measuring cylinder carefully. The egg was risen in the liquid when the liquid level becomes 870. Which means when 400, when 400 milliliters of seawater is mixed into this, which means density of egg and density of the mixture has been equal. So that is why egg is rising up. Egg is rising up, right? Now here, now egg is rising up, and which means there should be seawater 400 milliliters. There should be seawater 400 milliliters of seawater. Correct? And relative density is given. Relative density is given. Relative density 1.2. Next, the mass of the egg is, right? Mass of the egg is, okay. Now, one thing is, now volume is known, and here when egg floats, that's the main hint in the question. When egg floats, density of the mixture here and density of egg should be equal, then only it floats, right? So therefore, now I need to find the density of the mixture somehow. If the density of the mixture is known, which means density of egg is known. If density of egg is known, since volume is known, mass can be determined, right? So when this floats, see, when floats, density of egg equals density of mixture. Density of egg equals density of mixture, right? Density of mixture. Now water volume is known. Water volume is 400. Dekama 400 තියෙන්නේ. Very lazy. See, now we know if we need to find the resultant density, density is given by total mass over total volume. Density is given by total mass over total volume. See, density is given by total mass over total volume. Total mass can be written as m equals 0, right? This is MOV, but we know m equals 0, right? Then this is total mass is, look at the word, total mass is mass of water plus mass of seawater, right? Total volume is volume of water plus volume of seawater, right? Now mass of water can be written as volume of water times density of water plus volume of seawater times density of seawater over volume of water plus volume of seawater, right? Apply these values. Now, if relative densities are given without converting to density, we can go ahead with relative density itself. That is fine, right? Or else, if needed, you can convert that as well. Either way is fine. See? Either way is fine. Final answer is a mass. Mass is 0. Then we have to convert. Anyway, we have to convert. I'll be converting here. VW 400. Now let's go with what's the given unit? Grams. Given unit is grams. Right. Let's go with cubic centimeter itself. That's fine. You know 1 milliliter is 1 cubic centimeter, right? 1 milliliter equals 1 cubic centimeter, right? So I'll go with the same. This is 400 and density of water is 1000 and this is also 400. Density is 1200 over VW plus VSW again 800. 400 plus 400, 800. Right? 0, 0 to 0, 0 to 0 to 0. Cancels. What's the value? Rho equals. Now by 4 we can cancel this again. By 4. Can't we? Yeah. By 4. 4 to 2. Right? Then Here 1000 remains. Here 1200 remains. It's right? 2200 over 2, 1100. 1100. Right. Now we need the mass, which means density of the egg is this. Possible, because initially it was drawn. Initially it was drawn when there is in water medium. So it should be something greater than water. It's an acceptable value, right? Now we need m. M is given by 0. M equals 0. We need mass. Now volume is 70. 70. 10 to the power minus 6. That is in milliliters. Milliliters ke lage yaane cubic centimeters. Cubic centimeters to cubic meters 10 to the power minus 6 times rho 1100. M equals 11 times 7 ke yaane 77 times 10 to the power minus 3 remains. This is in kilograms. So which means 77 grams. 77 grams. Answer 3. This is a good question. For 19, answer 3. That's a good question. A tricky question. Not that difficult, not that hard, but there are a few things to be understood. If you grab these things, if you understood these things properly only, you will tackle the question. Right? Otherwise, if you didn't get what this data means, and about this logic also, if you didn't get the hint, then you will get stuck. Otherwise, if you get the question at once, question is easier. That's a tricky question. Right? Try it out. $20. Value of maximum power output across the variable resistor R of the circuit case. Right. About a circuit, there's a theory, there's a point that you need to know about power dissipation. That is, maximum power dissipation of a circuit occurs when internal resistance equals external resistance of the circuit. Right. That is proved using a graph in electricity. Right. So therefore, this is a logic. This is a logic. Maximum power dissipation. Maximum power dissipation is when external resistance equals internal resistance, right? So therefore, now the internal resistance is given 2 ohms, which means external resistance should have to be 2 ohms as well, right? So therefore, R equals 2 ohms. Therefore, R equals 2 ohms. Now the given circuit is this. 8 volts, 2 ohms, 2 ohms. Right? Apply Kirchhoff's laws. To get the current, apply Kirchhoff's laws. Sigma equals sigma ER. Sigma E only 8. Sigma ER only one current flows. Let's say I. R plus R 2 plus 2. So I equals 2 amperes. If I is known, P is given by P is I squared R. P is I squared 2 squared R is 2. 8 volts. 8 volts. Answer 2. For 20, answer 2. Right? Right. Next. Uh, 21. 21. There is an ohm meter. Ohm meter. A modified ohm meter from a galvanometer of internal resistance 49 ohms is shown in the figure. If the full scale deflection current of the galvanometer is 1 milliampere, the value of variable resistor S when the reading 0, when reading 0 on ohm meter scale is right. If reading of the ohm meter is 0, which means there is nothing connected between T1 and T2. There is nothing connected between T1 and T2. Any ohm meter is solved using Kirchhoff's laws. Any ohm meter is solved using Kirchhoff's laws. Right? So galvanometer S and there's nothing here that is connected T1, T2. Two 2.5 1 ohm. 2.5 volts 1 ohm. This is also given 49 ohms. That's all. Right. Apply Kirchhoff's laws. Sigma equals sigma ER. Now the current is known. Maximum current deflection is 1 milliampere. So current flows here is 1 milliampere. Right? Sigma E 2.5. Sigma ER, I is 1 milliampere. Right? R measuring 1 එකක් තියෙනවා 1 plus 49 plus S. Right? Then this is 2500. Ne? This is 50 plus S. S equals 2450 ohms. 2450. Answer 4. See how easy that is? Very easy, yeah? Very easy. You just need to know this theory. Ohm meter is solved using Kirchhoff's laws. Kirchhoff's laws දන්නවා නම් මේක solve කරන්න දන්නවා නම් නිකම්ම ගන්න තියෙන ලකුණු. Next. 22. Radius of the orbit of a geostationary satellite of mass m is r. If the mass of Earth is capital M and the radius is r, capital R, the total energy of the satellite at the orbit is right. Total energy. 22. Gravitational fields. Gravitational fields. Now from Earth's surface, the satellite is r distance away, right? Radius of orbit of geostationary satellite of mass. Okay. Radius of orbit, which means this whole thing is r, and this is capital R. Simple M. Okay. Total energy. So we know there are two energy components in a gravitational field: kinetic energy and gravitational potential energy. Right? See, kinetic energy can be written as either GMMO 2R, either GMMO 2R, 2R, R in the sense that's the total distance. Let me write it as X, since one R is also given here, 2X, or half mv squared as usual. And potential energy can be written as minus GMM over R. Right? Now we need the total energy. Total energy again make addition. Total energy again make addition. Right? Say total energy. Total energy is the addition of kinetic energy and potential energy. Simple. Kinetic energy, GMM over. This is also x, GMM over 2x. X means distance from center of mass to center of mass, right? R, GMM over 2R. Potential energy minus GMM over R over simple R in this case. Simplify this. Simplify this. Then common derivative is 2R. 2R. Then is GMM minus 2GMM. So total energy is minus GMM over 2R. Minus GMM over 2R. Now in the answers, no G is given, that is converted to simple M. For that you can use the general equation of gravitational field intensity at surface. Gravitational field intensity at surface can be written as G equals GM over R squared. G equals GM over R squared. So therefore GM equals GR squared. GM equals GR squared. Fine. Apply that here. Minus, instead of GM, you can write GR squared M over 2R. Minus GR squared M over 2R. Minus GR squared M over 2R. 2 ne? 422 answer 2. '23. Metal sodium work function 2.28 electron volts is illuminated by a monochromatic light. All the electrons released from sodium is stopped by a potential of 1.51 volts. Stop potential means stopping voltage. That is the stopping voltage. Vs. That is called Vs in photoelectric effect. The energy of incident photon is. Apply the general equation of photoelectric effect. General equation of photoelectric effect is E equals phi plus Kmax. And Kmax can be expanded as EVS. Phi is work function. Listen, phi is work function. E, charge of an electron. Vs, stopping potential. Stopping potential. Right? Now, work function is given in electron volts. No? Electron volts. Electron volts that is charge of an electron times the joule value. I think we discussed in a previous paper. Now, if we are to convert joules to, or the other way, electron volts to joules, if we are to convert electron volts to joules, what we do is multiplying this with charge of an electron. So therefore, now the final answer is also asked in electron volts. Then I will keep those values with the charge of an electron, considering E, considering as E. Then E equals, this is 2.28. 2.28 plus this is 1.51. 1.51. So this is in electron volts. Now for your clarity, if I write the unit, this is in electron volts. This is 1.51. EVS ne? EVS can volts. Same. That is 3.79 ne? 3.79, very straightforward. 23, answer 5. 24. What is the phenomenon that cannot be explained by Bernoulli's principle? Attraction of a person who is standing closer to a railway track towards a train traveling fast. Correct. Because when the train travels fast, now if there is something that can be explained by Bernoulli's principle, it should be able to explain by the pressure difference. Right? Bernoulli's principle එක explain කරන්න ඕන නම් වාට pressure difference එකෙන් explain කරන්න පුළුවන් වෙන්න ඕනේ. මොකද Bernoulli කියලා කියන්නේ that's all about the force created with the pressure difference. That is all about the force created with the pressure difference. ඒ විදිහට explain කරන්න පුළුවන් නම් ඒ විදිහට කරන්න පුළුවන්. Bernoulli වලින් කරන්න පුළුවන් නැත්නම් බෑ. Attraction of person towards the train, yes, because when the train moves fast, so always pressure and velocity are opposite. Always pressure and velocity are opposite. What's the question number 24? Pressure and velocity are opposite. Listen to the explanation. Listen. When the train moves, velocity increases. When velocity increases, pressure decreases. When pressure decreases, now compared to the person, pressure at the train is decreased value. So therefore, the force exerts from high pressure to low pressure. So that person is attracting towards the train like this. Right? Second one, increasing the velocity of water when it is moving from a big tube to a small tube. No. It increases because of the continuity equation, not Bernoulli's equation. A1 V1 equals A2 V2. So product AV is K. Product AV is K. That is not Bernoulli's equation. A Bernoulli means that is continuity equation. That is continuity equation. So 2 is wrong. 2 is wrong. 2 is wrong. 3. Removal of light roofing plates. Light roofing plates when there's a heavy wind. Yes. When there's heavy wind, again what happens is velocity increases, pressure decreases. Since the pressure difference, due to the pressure difference, a force from high pressure to low pressure exerts from inside of home to the outside. So it takes the roofs away. Drying off surrounding springs when the water moves in tunnels. Yes, when water moves in tunnels, velocity increases. When velocity increases, what happens is, now if this is the tunnel, when water moves in the tunnel, when velocity increases, pressure decreases. Then pressure in the surroundings is higher. So therefore, from high pressure to low pressure, force exerts. From high pressure to low pressure, force exerts. With that force, all these springs are coming towards this main flow. They are coming towards the main flow. Right? So that is why it's drying off. That's why it's called drying off. One of the examples is after the project Umaoy කියලා project එකක් තිබි දන්නවනේ බදුල්ලේ Umaoy කියලා project එකක් කරන්නේ දන්නවනේ ඔය මේ Umaoy project එකෙන් පස්සේ තාමත් ගොඩක් ගෙවල් වලට වතුර නැහැ ඒ කියන්නේ කලින් තිබ්බ ලින්දවල් හිඳිලා right Umaoy project එකෙන් පස්සේ Umaoy කියලා ලොකු ටනල් එකක් මට values මතක නැහැ it carries a massive amount of water, right? Then after the project of Umaoy, there are cases with the dried wells in the households around. මේකම තමයි reason එක. right? Natural flow එක තියෙද්දි මේක naturally හැදිලා තියෙන එක තියෙනකොට ඉතින් එහෙම ලොකු ප්‍රශ්නයක් නැතුව තියෙනවා. ඒ කියන්නේ දැන් කොහොමත් main stream එක පැත්තට තමයි හැම එකක් මෙන්නේ අර දන්නවනේ. කියන්නේ from fountains to river water flows. That is because of this. කොහොමත් main stream එක දැන් river එකක් නා river එකට තමයි ඔක්කොම පොඩි streams ටික ඇවිල්ලා fountains ටික ඇවිල්ලා springs ටික ඇවිල්ලා එන්නේ. right? ඒක natural flow එකක් වෙද්දී ඒක naturally තියෙනවා. හැබැයි අපි artificial flow එකක් මේ විදිහට හැදුවොත් අර springs ටික හින්දෙනවා. ඒක dry off වෙනවා. ඒක තමයි කියන්නේ. That's a practical scenario. ඔක උමාවය ප්‍රොජෙක්ට් එකේ වුණා. බදුල්ලේ කට්ටිය ඉන්නවනම් අහලා බලන්න. හරි මේ ක්ලාස් එකේ නන්නේ මේ බදුල්ලේ යාළුවෝ ඉන්නවනම් අහලා බලන්න වතුර තියනවද කියලා. මේ දැන් අවුරුදු 5ක් විතර වෙනවා. ඔව් it's around 5-6 years now. මේ yes වතුර නැති වුණා ඒගොල්ලන්ට. Right. Spraying process of a spray pump. Yes, correct. Because in a spray pump, that's a popular question as well. In a spray pump, with the high speed airflow, pressure decreases. When pressure decreases, with the force created from high pressure low pressure, the spray comes out. Same thing happens in a perfume bottle as well. Answer is 2. For 24, answer 2. Next. Two solenoids are shown in the figure. The most accurate representation of magnetic field lines, magnetic fields, right? Solenoids. If current flows in clockwise direction around a solenoid N, that is called a south pole. If current flows in the anticlockwise direction in a solenoid pole, that is called a north pole, right? Always magnetic field lines are from N to S. Magnetic field lines are from N to S, right? Now in the first one, first thing is you have to identify these poles. In the first one, the current flow is like this. And here the current flow is like this. Right? Okay. Now, see, if you check this direction, comes in from here and goes from behind. Direction of current flow is anti-clockwise. So there is a north pole. This is a north pole, which means this is a south pole. Right? And here, coming from behind and coming to the front. Direction of current flow is clockwise. There is a south pole. This is a south pole, which means this is a north pole. Right? Magnetic field lines are always from N to S. Then magnetic field lines should be from N to S. And S and S are repulsions. S and S means repulsions. And magnetic field lines are from N to S. Away from men. N to S. Then, what's the answer? 4. Answer 4. Without checking poles, we can't say anything. Right? So checking poles is the thing comes from magnetic fields here. (26) Path of a ray of light through a glass sphere is shown in the figure. If the angle subtended by the arc AB of the center is 100. Okay, let's break it down. What's the question number? 26. Okay. Path of light ray through a glass space shown in the figure. If the angle subtended by arc AB on the center is 100. Right. Now, if I draw normals here, normals are intersected at the center. Normals here. Then this angle is given as 100. Correct? The angle is given as 100. And the deviation of the ray is 80. Deviation of a ray is the angle between original direction of light ray and the final direction of light ray. Original direction is this. Final direction is this. So this has to be 80. This has to be 80. Right, what's the question now? The refractive index of glass is, okay. To find refractive index, the only equation we have is Snell's equation. To find the refractive index, only equation we have is Snell's equation, right? If this is 80, see now we know if this is a sphere and if this is the center of the sphere, these two are radius, they are equal. They are equal. Anna, if they are equal to satisfy 180 here, if this is 100, these two should be 40 and 40. These two should be 40 and 40, right? Okay. Then what about the other side? Make a 80. There is 80. This is an external angle. External angle has become 80. 100 if the angle subtended by arc AB on center is 100. Then let's go this way. If this is 80, these two are 40 and 40 again. Yeah. Why? Because listen, these two are two congruent triangles, right? If these sides are equal, these two sides should also be equal and symmetric, right? This diagram is symmetric. Since there is symmetry, yeah, now it's done. These two are also equal, which means these two should be 40 and 40 again. Because this is the external angle. You know, external angle equals addition of two opposite angles of a triangle, right? Okay, now if that is known, which means I is known 80. This is 80. Okay, now it's done. Apply Snell's equation. N1 sin I equals N2 sin R. N1 is 1, sin I is sin 80. Right? I N2 කියන්නේ අපිට ඕන එක N sin R is between the ray with the normal 40, sin 40. So N is sin 80 over sin 40. Sin 80 over sin 40. Sin 80 over sin 40 get 3. For 26, answer 3. That's a good one with a good geometry. Alright. O-level geometry එක use කරන්න ඕනේ. ඉතින් O-levels වල අපි කතා කරන geometry පාඩම් ටිකක් තියෙනවානේ. හරි. අනේ geometry ටික ඕනේ A-levels වලටත්. Right? Twenty-seven. The variation of pressure T and volume V of a gas in a cyclic process is shown in the figure. Work done during the process is. That's a cyclic process. Very straightforward. Work done in a cyclic process is given by area of loop. Work done by a cyclic process is given by area of loop. Cyclic නම් හරි ලේසි. කෙලින්ම loop එකේ area එක ගන්න. Work done equals work done in a cyclic process equals area of loop. That's it. ඒක දන්නවනම් ගාන ඉවරයි. That's a trapezium. That's a trapezium. Trapezium. මෙතනින් ඇවිල්ලා තියෙනවා 1 උඩින් එනවා 1 to 3 කියන 2 1 plus 2 1 plus 2 times 10 to the power minus 3 over 2 into perpendicular distance එක 10 to the power 5 to 1 times 10 to the power 5 1 times 10 to the power 5 මෙතනින් එන්නේ 3 over 2 මෙතනින් එනවා 10 to the power 2. 300 over 2 again 150. And about the sign, listen, about the sign, if a process is clockwise, work is plus. If a process is anti-clockwise, work is minus. If a process is clockwise, delta W plus. If a process is anti-clockwise, delta W is minus. Then that is clockwise. So this is plus 150. Answer 1 for 27. 1. See how easy? $28. Variation between the electric field intensity and distance are in a certain electric field is shown in the diagram. Corresponding to best graph that represent the variation between potential and the distances. That's a very popular graph conversion we have in electric fields. But ED-VD conversions. ED-VD conversions, very popular in electric fields. 28. The relationship is this. We know E is given by minus delta V over D. E is minus delta V over D. So therefore, E equals minus gradient of VD. This is the gradient of VD. Right? එහෙනම් gradient එක check කළා තමයි දැන් ඕක හරවන්නේ. See? Now this is given. V with R. ED-VD conversion is very popular question now. මේක දන්නේ නැත්නම් අදම මේ set කරගන්න මේක popular question now. VD. Okay, look at here. Now knowing E, we are going to convert this to V, right? This is a relationship. Gradient of VD is negative value of gradient of VD is E. Now E is known, which means if E is known, we can presume the gradient like this. If E is known, which means we can get the gradient, right? Now here, look at here. Look at the board. Very careful. This part, E is positive. E is positive and constant. If E is positive, gradient should be negative, because E is negative gradient. E is negative gradient. So if E is positive, gradient should be negative. Gradient is negative. And E is constant. E is constant. So gradient should be constant. Second part, value of E is less. Value of E is less. But still, E is positive. If E is positive, gradient is negative. And if E is constant, gradient is constant. Negative and constant again. But this value is a little bit less. This is less compared to the previous value. This is high. And this part, E is negative. If E is negative, gradient is positive. So this part, gradient is positive. And E is constant, gradient is constant. Right? එහෙනම් මෙතන එන්නේ high negative gradient එකක්. Higher negative gradient එකක්. See? So you know what negative gradients are. A higher negative gradient and comparatively lower negative gradient and a positive gradient. Basic shape එක මෙහෙමයක් තියෙන positive gradient මේක straight line එකක්. Positive gradient, this is a straight line. 1, 1. For 28, answer 1. $29. According to the figure, a small ball P is kept inside a conical shape container with a smooth surface is rotated around XY axis. Then the ball P is at rest relative to the surface at the position as shown in the diagram. Alright. If the speed of ball is V, then V squared is given by. Okay. Circular motion ആണ് ഇതിന്. P is here. R 20. Okay. Right. So we know from circular motion. Now, when this undergoes in a circular motion, right? What we usually do is we apply F equals ma towards center. We have to apply F equals ma towards center, right? And I think force mark karagatta. Sorry, at least force mark karagatta. F equals ma damma. Damma lang ඔය කියන answer එක ගන්න පුළුවන් වෙන්න ඕනේ. Right? Mark forces and apply F equals ma towards center. That's a usual thing we do for any circular motion. Yeah, that's a normal thing, usual thing we do for any circular motion. Do the same. Right? If I mark R, reaction is perpendicular to the surface. So reaction will be something like this. And if I mark MG is vertical, like this. Right? So extend these lines to see these angles. Now we need angles. 20 කියන angle එකෙන් ඔක්කොම දීලා තියෙන්නේ. හරි 20 ලිම් එක මාක් කරගන්නවා. 20, 90, then this is 70, this is 20 again. හරිනේ. අන්න 20 එකක් ආවා. Right. So first we can write vertical equilibrium. Because this is a horizontal circle. For horizontal circle we write vertical equilibriums. Right? Vertically upwards forces equals vertically downwards. Vertically upwards we have R sin 20. Vertically downwards mg. I consider this as 1. And then use F equals ma towards center. F equals ma towards center. Right? Then R cos 20. Only force acting towards center is R cos 20. R cos 20 equals MA, what is R? V squared. Speed. So we know A can be expanded as V squared dou R or R omega squared. Now I'll go with V squared dou R. Equation 2. Divide these two. Very straightforward. Right? Divide these two. 1 over 2. 1 over 2. R sin 20 over R cos 20. R sin 20 over R cos 20 equals mg over mv squared over R. R to R cancels. Sin 20 over cos 20 and tan 20. Because sin over cos is tan, sin 20 over cos 20 and tan 20. And here m to m cancels. R goes up, gr over v squared. So v squared is given by gr over tan 20. gr over tan 20. gr over tan 20, answer 5. For 29, answer 5. This is the usual thing, the normal thing we do in a circular motion, applying F equals ma towards center. Next, 30. Ten volts. C1 6 microfarads. Okay, 3, 9, 6. Right. What's the question? There is no internal resistance. There is no internal resistance of the cell given in the circuit. There is no internal resistance of the cell given in the circuit. And the electromotive force is 10 volts. The charge and the potential difference of capacitor C1 is. Charge and the potential difference of capacitor C1 is. C1 කියන්නේ මෙයා. හරි. Charge එකයි potential difference එකයි. Now, first what I see is these two capacitors are in a parallel combination. Parallel combination in capacitors means we can just add capacitors if they are in parallel combination. So therefore, I'm going to simplify these two. See, I'm going to simplify these two. If these two are simplified, what we get is this 6 microfarads here, 9 plus 3 කියන්නේ 12. 1 12 here. 12 microfarads here and 6 microfarads here. Fine. What's the first question? The charge and potential difference. Okay, first I will get the potential difference. We can apply potential divider for capacitors. As we have a potential divider for resistors, we have a potential divider for capacitors as well. දෙකම තියෙනවා. Capacitors වල දාමු. මේකනේ ඕනේ. Let's say V. So V is given by total potential 10 over addition of capacitors into, now this is as the opposite of resistors. If I need the potential difference across 6, multiply it with 12. Simplify this. V equals 10 over 18 times 12. 6 times 2, 6 times 3. So V is 20 over 3. 20 over 3 means 6.67. So 1 is known. 6.67. And then charge. Q equals CV. Equation of charge of a capacitor is CV. Q equals CV. C is 6. V is 20 over 3. 20 over 3. Which means Q equals 40 microcoulombs. Charge 40 microcoulombs. 40 and 6.67 answer 4. For 30 answer 4. Answer 4. Thirty-one. According to the figure, wooden block with a volume 0.04 cubic meters is floating on the water. 75% of the total volume is immersed in water. Right. 75% is immersed in water. 75% is immersed. Right. 75% is immersed in water. The required minimum vertical force in order to immerse the wooden block totally in water is. Right. Okay, now, since we don't have any idea about Rho is given, right? No worries. Then directly we can apply delta equations. Delta U equals delta V rho G. Delta U. Delta equation and the delta U equals delta V rho G, right? Or else delta mg මේ ඔක්කොම ලියන්න පුළුවන්. Delta mg equals delta U. Delta mg is the additional force now. Required minimum vertical force. That will be delta mg. මේක තමයි ඕනේ force එක. That is delta U. That is delta V rho G. Right? Delta V is the difference. Difference needed is only this 25%. 25%. And the total volume is 0.04. එහෙනම් මෙයාගේ 25. 0.04 into 25 rho 1000 G. Simplify this. Simplify this. Very easy. 0 to 0 to 0 to 0 cancels. 100. 100 newtons. 100, answer 3. For 31, answer 3. 100 newtons. Next. Next. 32. 32. According to the figure, tubes P and Q with radii 2R and R respectively are connected and kept horizontally. A laminar flow of a viscous liquid is allowed to flow in the tubes. The lengths of the tubes are equal. Consider the following statements. The volume flow rates through both tubes are equal. Correct. Because volume flow rate into a junction equals volume flow rate out from a junction. Right? So therefore volume flow rates are equal. Then only a laminar flow can be flown. Sorry. A. Incoming volume flow rate equals incoming volume flow rate Vd equals outgoing Vd. So A is correct. A is correct. B. B. The pressure difference between the two ends of tube P is 16 times of tube Q. That you can check. To check the pressure difference, use Poisson's equation. Poisson's equation is V over T equals 5 delta P A to the power 4, again radius 8 theta L. Right? So apply this for these two tubes. Right? For the first tube, V over T equals 5. Let's consider delta P of P as delta PP. Right? Pressure difference again, the pressure difference between now. Right? So let's say this is delta PP. And R is 2R, it's given. Yeah. 2R to the power 4 over 8 eta L. And for the other one, V over T 5 delta PQ R to the power 4 over 8 eta L. Right? Right? Divide these two or equate these two. Anything is fine. Equate these two. Then 5 to 5 to 8 eta L to 8 eta L to everything cancels. What's remaining is, see, what's remaining is delta P 16 R to the power 4 equals, from the other side, delta PQ times R to the power 4 remains. R to the power 4 to R to the power 4 cancels. Now make this ratio. What is asked? The pressure difference between two ends of the tube P is 16 times that of Q. The ratio then delta P over delta P Q is 1 or 16. Which means the other way, that color, opposite again. 16 P equals PQ. PQ is 16 times of P. You can have it. That is strong. B is strong. B is strong. C. Speed of liquid at Q is twice that of P. Speed check करना होना A1 V1 equals A2 V2. C. To check on C, let me do here. To check on C, right? We know A1 V1 equals A2 V2. Apply and see. Speed of liquid Q is twice scale, right? So let's say this is 5R squared, then 5 2R squared Vp, and this one 5R squared Vq, right? 5 to R squared to R squared cancels. 4Vp equals Vq. That is not 2 times, that is 4 times, right? That is 4 times. So what is correct? Only A. The pressure difference between the two ends of P is 16 times that of Q. P is 16 times. Correct statements. A is correct. The pressure difference between the two ends of tube P is 16 times that of Q. The pressure difference between the ends of wrong. Pressure difference between the two ends of P is 16 times that of Q. No, wrong. Only A. Answer 1. $33. Right. 33. The current entered from midpoint of the topmost form resistor in the resistor network exists from midpoint of the bottommost form resistor. As shown in the figure, the equivalent resistance between A and B terminals is. Right. When the current flows from between, it's better to split the resistor into two. Right. Now, if a resistor is given as now like this, if a current flow is given in middle of the resistor, what you can do is you can split the resistor. Split that. Right? Current flow common divide by n. एक split करना है तो हम lazy. Right? So I'll do like this. Like this. With the split. 4 ohms now, that is 2 ohms, 2 ohms now. With the split. 2 ohms, 2 ohms. 2, 2, 2. 2, 2, 2. 6, 6. 2, 2, 2. Right. Now simplify this. 2, 2, 2 means they are series. 2, 2, 2, 6. Then 6 and 6 are parallel. 6 and 6 can then 3. 3 ne era me okkormen 3 එක. මේක simplify වුණා මෙතෙන්ට එනවා 3 එක. Similarly, from this side also same. This is 3. Okay, now what's remaining is 2, 3, 2. 2, 3, 2 in series combination. Then 5, 7. Method 7. Then finally what you have is 7, 7 parallel. 7, 7 parallel means final answer is 702. 3.5. 7 and 7 parallel. 702. 3.5. Answer 2. 33. Answer 2. So there are easier questions here and there. You have to peek into the questions and see what's easier, right? සමහර දැන් වල අමාරු වෙලා තියෙනවා. අමාරුවක් තිබ්බොත් skip කරලා ගිහිල්ලා lazy එක කරලා time එක balance කරගන්න ඕනේ. $34. Okay. According to the figures, our bubble has been formed at the end of the capillary tube bay and air trapped inside the bubble using a water column. What is the best graph that represents the variation of pressure from O to A? Right. A normal question, a normal question. Right. So we'll draw from here to here. Distance and pressure. So we know if we jump into a liquid meniscus, pressure increases by 2TOR. If you jump out from a liquid meniscus, pressure decreases by 2TOR. Pressure difference is given by 2TOR. Delta P is 2TOR. Right, starting from here to here, that is atmospheric pressure. From here to here, atmospheric pressure. And at this point, we are jumping out from the meniscus. Meniscus is here. We are jumping out from the meniscus. So it decreases by 2TOR. And from here to here, that is constant again because pressure at a liquid at the same horizontal level. Pressure of a liquid at a same horizontal level is equal. Right? And then jumping into a meniscus here, jumping in. But that is greater than atmospheric pressure because the reason is this is also meniscus. This is also meniscus. This is inside a meniscus. This area is inside a meniscus. So that is greater than atmospheric pressure. And from here to here, that is constant. And at this point again, it should be back at atmospheric pressure. Right? 1, 34, 1. Pagala check kalla dinno ne. $35. We have done a similar question before as well. I think in paper 1 or paper 2. Right? Magnetic flux density at the center, always that becomes 0 if that's a circle. If that's a circle, magnetic flux density at a center becomes 0. Right? When current divides. Right? 0. Answer 5. For 35, answer 5. 36. 36 is a different question. Okay. Look at here. 36. It's a good one, different one. Right. Right. So above we have some wave fronts. Wave fronts. We know distance between two wave fronts is lambda. Distance between two wave fronts is lambda. And C and D are marked. Right. Now if this is, see, if this is C, if this is C, and if this part is D, right? This can be written as C minus D, no? This can be written as C minus D, right? And if I check that from above, here, if you check this from above, here we have two wavefronts, eh? Yeah, two wavefronts. Then between these two wavefronts, this distance has to be 2 lambda. Between two wavefronts, the distance has to be 2 lambda, right? Okay, now, yes, we can write a ratio, né? Because these two triangles are going to be congruent. These two triangles are going to be congruent. So I'm going to write the ratio. 2 lambda to this equals, yeah, may triangle again 2 lambda to this is known A and this is known as B. So we can write this as 2 lambda to this ratio A. And here C minus D to this ratio again A plus B. So lambda equals A times C minus D over 2 times A plus B. A times C minus D over 2 times A plus B. Answer 2. For 36, answer 2. Right? A different question, but if you get what it is, what's given in the question probably, easily we can do using congruent triangles. Congruent triangles. 37. Okay. Now in a question like 37, you better draw and see. You better draw it and see. One person is here and the other one is somewhere here. Like this. Right? Yeah, now they are seeing, they are observing that C. They are observing C. Right? The way that two persons A and B who look at bulb C, which is in a tank filled with water. B is sitting and A is standing on stage behind B. What is the most correct statement regarding the apparent position of the bulb observed by A and B? Right? Light rays under Light rays under the theory is this. See? The theory part involves here is now if there's a light source inside water or any refractive medium, right? This is how light rays travels. This is how light rays travels. Right? In all directions, this is how it travels. Right? This is how it travels. Up until the what? Critical angle. Up until the critical angle, this is how it travels. Now here also the same. Right? The light rays that may unknown. This is the vertical line. This is the vertical line. Say this is the light ray which goes to the eye of this person. Right? And the other one is standing behind. Right. Then the image of this first one is here. आप image locate करेगा वो. Image of B. Image of B is here. Right. Now always we will see the image at the place where these two light rays are intersected. Right. That's the same idea we have from real depth and apparent depth. Right. मैंने मेरी direction में था मेरा light पे मेरी direction में पेन वगैरह मेरे नाम पे. Okay, for A, ඒට තව light ray එකක් අඳින්න ඕනේ. මේ හරියෙන් අඳිමු. මෙහෙන් එන්න බෑනේ. මේ පැත්තෙන් light ray ගෙන්න වෙන්නේ. Right? So from A, the light ray is coming like this. From A, another light ray is coming like this. So its image will be somewhere here. Its image is somewhere here. Right? Current images දෙකක් තියෙනවනේ. Then position of bulb observed by B is below. Yeah, B is below the position by A. Yeah, 2. Now, in such a case, in such kind of a case, draw ray diagrams and see. Draw ray diagrams and try to locate. Try to locate the image. 38. The density of vacuum which can be produced in laboratory is 10 to the power minus 17 density. Ne? Okay. If there are 3 times 10 to the power 6 molecules in 1 cubic meter and temperature is 27, the pressure is Boltzmann's constant is given. Right. We have only two equations having Boltzmann's constant. One is kinetic energy of a molecule, gas molecule, 3/2 kT. Another one is PV equals nkt, right? Pressure is given, and no, pressure is asked, right? So let's go with PV equals nkt. PV equals nkt. We need pressure, volume. If there are 3 times 10 to the power 6 molecules in 1 cubic meter, so volume is 1. Number of molecules 3 times 10 to the power 6. K, Boltzmann's constant, 1.4 10 to the power minus 23. 1.4 10 to the power minus 23. 300. Right? Simplify this. 3 times 3 is 9. 9 times 1.4 क्या निकलेगा? 1.26 है ना? 9 times 1.4. Yeah, 12.6. Which means 3 times 3 is 9. 9 times 1.4 is 12.6. Times remaining powers are 10 to the power 6, 10 to the power 8. Then here 10 to the power minus 15. So this is 1.26 times 10 to the power minus 14. That's not given there. Three times 3, 9. 9 times 1.4, 12.6. Right? And 10 to the power 6, 10 to the power 8. Then minus 15. Minus 15. There's a small typo in one of the answers. Make both answer as 10 to the power minus 14. Na? Make this 10 to the power minus 14. Sorry. 1.26. 1.26. Hurry. Yeah. Make this 10 to the power minus 14 and consider answer as answer 4. Consider answer as answer 4. 39. Two wooden blocks P and Q of different mass are kept in touch and horizontal force F is applied on P. Mass of Q is greater than the mass of P in figure. Mass of Q is greater. Right. MQ is greater than MP. Right. Consider the following statements. If the table is smooth, force applied on Q by P is less than F over 2. Right. To check the internal force, see, you know these are Easier one. If you need to check this internal force, first find the acceleration. And now what we need to determine is this R and R, right? And let's consider this as MP and MQ, masses as MP and MQ, right? Apply F equals MA for whole system to get acceleration, right? F is F, M, MP plus MQ, A. So acceleration of the system is this F over MP plus MQ, right? Now if you need to get R, apply F equals MA for Q. That is easy, right? F equals MA again in this direction. R equals MQ A. A is F over MP over MQ. MP plus MQ. Right? For the ease of comparing, I'm going to divide this numerator and denominator both by MQ. I'm going to divide both numerator and denominator by MQ. Right? Then this becomes F, and here MP over MQ plus 1. Now you can compare. Right? So we know F over 2 comes if these two are equal. On equal M and M equal. If they are M and M, these two cancels. 1 plus 1 can 2. F over 2. After compare F over 2. Right? If the table is smooth, force applied on Q by P is less than F over 2. Check we know MQ is greater. If MQ is greater, this value is less than 1. That is less than 1. When that is less than 1, what happens is this denominator becomes less. When denominator is less, R increases. So actually this is greater than F over 2. Actually this value is greater than F over 2. Actually this value is greater than F over 2. Less than again, so A is strong. A is strong. A is wrong. Next one. B. If the table is rough, force applied on Q by P is greater than F over 2. If the table is rough, the difference is, now we can easily add that change. We can add that difference here. If the table is rough, there will be a friction on Q. Let's say FQ, like this. There will be a friction on Q. Then when you write this, it becomes R minus FQ. It becomes R minus FQ equals this. R minus FQ. Then R is FQ plus this value. FQ plus this value. Therefore, that will be greater than F over 2. That will be greater than F over 2. Right? Now, that will not be මෙතන කොහොමද greater than නෙමෙයි. ඒක කොහොමත් හරි. ඒක කොහොමත් හරි. මෙයා F නැති වුණත් ඒක හරි. Because anyway this part was greater than F over 2. This part was greater than F over 2. Now if FQ is added, that is for sure greater than F over 2. Right? So this is correct. Which means B is correct. See, although the table is rough or smooth, the force on Q and P remains same. No, that's getting different. So therefore only B. Only B. So only B. Uh, 40. To increase the sensitivity of potentiometer in the figure. Sensitivity of a potentiometer. Now you have to know about sensitivity. Sensitivity is a common term for any measuring instrument. One measuring instrument take sensitivity, right? Always sensitivity is what? The change we get for a unit change of the quantity that we are going to measure. Now, as an example, sensitivity of a thermometer is, let's say, mercury in glass thermometer. Sensitivity of a mercury in glass thermometer is the delta H, difference in height per unit temperature difference per 1 degree Celsius. Now, this is a potentiometer. In a potentiometer, it should be the length, balance length per 1 volt. per unit voltage, per 1 volt. So therefore sensitivity is this. See, now we know for a potentiometer, VAC equals KL. VAC equals KL. Sensitivity is L over VAC. That is actually 1 over K. Sensitivity is 1 over K. This is called sensitivity. This is called sensitivity of a potentiometer. This is called sensitivity. Sensitivity of a potentiometer. Right? But we know K is total potential difference over total length of the potentiometer by N. Right? Now, if these things are known, now we can start the argument. To increase sensitivity, ES should be decreased here now. ES. There's no change from ES. Because ES is not involved in here. Then K වෙනස් කරගන්න ඕනේ. Sensitivity වෙනස් කරන්න ඕන නම් K තමයි වෙනස් කරන්න ඕනේ. K වලට නෑ ES එක. K වලට නැහැ. R should be increased. R කියන්නේ above. When R increases, listen. When R increases, potential difference across R increases because V equals IR. When R increases, potential difference across R increases according to V equals IR. When that increases, potential difference across potentiometer wire decreases. හරිනේ මෙතන එක සර්කිට් එකක් තියෙන්නේ. හරිනේ මේ above loop එක. මේ තියෙන potentiometer එකේ above loop එක. Above loop. මේ තියෙන්නේ AB, potentiometer wire. මේ R. So when R increases, now only voltage supplier here is E. Then when R increases, potential difference across R increases, then the remainder will be across AB that decreases. What happens? When that decreases, VAB decreases. When VAB decreases, K decreases. When K decreases, sensitivity increases. That is correct. Right? And check others. R should be increased after increasing ES. No. R should be decreased. No. E should be decreased. And R should be increased. And nega check කරන්න ඕනේ. E එක decrease කරාම හරියනවද කියලා බලන්න වෙනවා. E. What about T? Now if E decreases, listen. If E decreases, potential difference across AB decreases. ඒකත් හරිනේ මේ. If E decreases, මෙයාත් decrease වෙනවා නේ ඒකත් හරි. දෙකම හරි. ඒ කියන්නේ 5. For 40 answer 5. For 40 answer 5. Forty-one. A horn emitting a note of frequency f naught is thrown vertically upwards with a velocity u. Right. The horn is thrown vertically upwards with u, emitting f naught. Sorry. Upwards with u. The variation of apparent frequency f with time t as observed by observer on ground is. Right. Now let's say ground is here. It will go up and then it comes down. This is the respective motion. Right? It goes up and comes down. Right. Now let's write an equation and see. For the first part up to here, we know it moves upwards with deceleration of g. Right? So which means for this motion, velocity at any point is given by apply v equals u plus at. Time math see, v equals u plus at. Then v equals u minus gt. V equals u minus gt. We know from Doppler's effect, f dash is given by velocity of sound through air with respect to velocity of sound through air with respect to observer and velocity of sound through air with respect to source times f naught real frequency. Right? Now, if you apply this to the first case, see, if you apply this to the first case, first scenario, first scenario, if you apply this to the first scenario, now observer is on ground. Yes, observer is on ground like this. To hear this sound, we should come towards the observer like this. Make a V dash, let's say V dash. Right. We should come towards the observer like this. And relative velocity V dash is opposite. Now, velocity of air with respect to observer again. Velocity of air with respect to observer, V plus V dash. Right? Sorry, with respect to observer again, only V. Observer is at rest. Observer is at rest. V over velocity of sound through air with respect to source V dash plus V. V dash plus V into real frequency f naught. But V dash is U minus GT. U minus GT plus V times f naught. Right. Now, from this we can get an idea about this shape. See, from this we can get an idea about the shape. Look at here. Look at here. When t increases, because time passes, when time passes, this increases. When t increases, this deducting part increases. Subtracting part increases. When subtracting part increases, this denominator decreases. This denominator decreases. Right? Denominator decreases. So therefore, f dash increases. F dash increases. F dash increase in trend increase in trend. 3 is strong. 3 increase in and since this is not a linear curve, T and F dash, they are non-linear. T and F dash, non-linear. Remove linear curves as well. 4 is also wrong. Right? And other thing is now after the maximum point, you have to check what happens after the maximum point. Now, side dash check right. Side dash check right. I pata check karo. Returning motion. Returning motion. Let's say V double dash. Starting from here. V equals U plus AT. V double dash equals U is 0 from here to here. U equals 0 plus GT. So V double dash equals GT. Fine. Then if you apply the equation of Doppler, again, let's say double dash, person is still at rest V and relative velocity is upwards now. Then there is V minus V double dash. V minus V double dash times f naught. So f double dash equals V over V minus GT f naught. Okay. Now again what happens is when time passes, when time goes, this part decreases, this increases. So still there is an increase in trend. Now the tie is between 1 and 2. Increase in trend and then tie is between 1 and 2. Right? Now see when the time goes, this goes up. It's increasing. So there is an increase in trend. Increase in increase in trend. 1 increase are constant. So in one you can see at the top that is going to be constant. So that is increasing. It should be 2. 41 answer 2. Right? That's a good one. Argue with these equations. 42. Okay, around this axis. As shown in the figure, vertical U-tube is filled with water. The maximum possible angular velocity around xy axis in order to avoid the spilling of water, angular velocity, water from the right term is density of water 1000, right? So we know inclination of a liquid surface is given by, the theory is this, inclination of a liquid surface is given by tan theta equals AOG, right? Inclination of a liquid surface is given by tan theta equals AOG. Inclination of a liquid surface is given by this, right? Not to spill ne. Now 4 centimeters තියෙනවා කියන්නේ. තව 4 centimeters මේ අඩු උඩට යන්න පුළුවන්. Right? එහෙනම් මේක තියෙන දැන් මෙහෙම. From this side it will go up to 4 centimeters and like this. Then this is altogether 8 centimeters. Because always when there is an acceleration, liquid surface inclines. Right? Now here due to centripetal acceleration and centripetal force, the liquid will be coming to here like this, centripetal force and centripetal acceleration, right? Okay, now the angle of liquid surface is here. This is the angle now, theta, and this is also 8. This is also 8. Right? Apply this equation. That's it. Apply the equation. Tan theta again. 8 over 8. 8 over 8. A. So we know in a circular motion, A can be written as what? R omega squared. R omega squared. Right? Then R is also 8. We make R. R is also 8. Then R omega squared over G 10. And 8 is centimeters. Ne? Then centimeters, meters karanda ode. This 8 is in centimeters. For this side, that is fine because it cancels. Then 8 times 10 to the power minus 2 omega squared. 8 to 8 cancels. Then this omega squared equals 1000 over 8 කියලා නේ 1000 over 8. 1000 over 8. So that is 125, which means omega squared can be written as 5 times 25. Right? So omega is root 25 is 5 ne? 5 root 5. Omega is 5 root 5. Answer for 42. Answer for. For 42. Answer for. Okay. 43. Bars PQ and R with equal cross-sectional areas are made of materials having the heat conductivities K1, K2 and K3 respectively. Q and R are equal in length. Q and R. Okay. Q and R are equal in length. L Q equals L R. And length of V is twice that of Q. Okay. Then L P is like 2LQ. Twice that of, okay. K1 greater than K2 greater than K3. Okay. Right. Again, they are like PQR. Okay. PQR. Then K1 is greater, K2, K3, like this. All curved surfaces are insulated lag and the two ends are kept at 0 and 100. Consider the following statements. A. Heat conductivity. Heat conductivity. A. The rate of flow of bars, rate of heat flow of bars P and Q are the same. What's the equation of heat flow? Q over T equals Ka delta theta over D. Right? Now, even though everything is same, K is different. When K is different, Q over T is different. So A is strong. A is strong. A is strong. A is strong. B. B. The temperature at the junction QR is greater than the temperature at midpoint of P. Temperature at midpoint of P is 50 because that's the same rod. Temperature at midpoint of P is 50. 0 and 100 of P. Midpoint is at 50. Midpoint is at 50. About the junction there, the temperature at junction QR is greater again. Okay. Higher heat conductivity means higher amount of heat flows. Lower heat conductivity means lower heat flows. Now, heat conductivity of Q is less. Heat conductivity of Q is less. Right? K of Q is less. So therefore, Q over T is also less. When lower amount of heat flows, what happens? Only a low amount of heat flows from 0 to the other side. Right? A lower amount of heat flows. So therefore, the midpoint check compared to this, a lower amount of heat flows, which means less heat. Not greater than, it should be less than. Heat so B is also wrong. C. Temperature gradient of R is greater than that of Q. Temperature gradient check this is called gradient of temperature. This is gradient of temperature. That is called gradient of temperature. Right? Subject it and check it out. Delta theta over D. Is given by Q over T over K. Q over T over K. Right? So, lesser the K, higher the temperature gradient. That is correct. R is greater than that of Q. Correct. C is correct. For 43, only C. Answer 2. For 43, answer 2. $44. 44. The ratio between number of turns. In a step down transformer is 20 to 1. If it works with efficiency 80%, the ratio of current in primary to current in secondary is. Right. So about a transformer, this is the general equation. General equation of a transformer is N1 over N2 equals V1 over V2 equals I2 over I1. 1 means primary coil, 1 is primary coil, and 2 is secondary coil. This is the equation of a general transformer. N can number of turns, V voltages, I currents. Current I2 over I1. Right? And here efficiency එකක් දීලා දෙනවනේ. හරි. එහෙනම් current එක පැත්තට අරගේ 100% utilize වෙන්නේ නැහැ. Only 80% will be utilized. Right? Okay. Then I'm going to connect these two. And yeah, 20 to 1 only 80%. Okay. Now from this 20 to 1, only 80% is utilized equals I2 over I1. From 20 to 1, only 80% is utilized. Effectiveness is 18. Efficiency is 18. Right? Simplify this. 0 to 0 cancels. 16 equals I2 over I1. Ratio is primary to secondary. 1 over 16 equals I1 over I2. Answer is 1 over 16. 3. 44. Answer 3. 45. Right. K and area A. Right. Distance between the plates of parallel plate capacitor is 2D and the effective area is A. A block of substance with a dielectric constant K, thickness D and area A over 2 is inserted in between the parallel plates of the capacitor. A over 2. Right? Inserts between the parallel plate capacitor. The equivalent capacitance of the system is. Right. Now, this part, now let's assume this plate has plus and this plate has minus. Right? So here in between these two, there is a capacitor. There will be a capacitor. And in this part also, there will be a capacitor. And in this part also, there will be a capacitor. So let's say C1, C2, and C3. Anyway, capacitors තුන simplify කරගන්න ඕනේ දැන්. මේ capacitors තුන simplify කරගත්තා නම් equivalent එක හොයාගන්න පුළුවන්. හරිනේ? මේ capacitors තුන simplify කරගන්න ඕනේ. මම we know C can be written as epsilon naught A over D. C can be written as epsilon naught A over D. This is a theory. This is a theory. Capacitance of a parallel plate capacitor can be written as C equals epsilon naught A over D. Now, apply this separately and find C1, C2 and C3. See, C1 is epsilon naught. For C1 only A over 2 comes. Right? Epsilon naught A over 2 over D. So which means C1 is epsilon naught A over 2D. And then C2. Right? If K is given, right, permittivity constant or relative permittivity is given, this is written as C equals K epsilon naught A over D. K epsilon naught A. And now K epsilon naught here. K epsilon naught A can A over 2 D. So C2 is K epsilon naught A over 2D. Right? Right? Then C3 epsilon naught A over 2 over 2D. Right? 2D. Then C3 equals C3. This is a simplification now. C3 equals epsilon naught A over 4D. Right? Okay. Now, in these capacitors, look at here, in these capacitors, plus to minus are connected, which means these two are in a series combination. Capacitors in series combination are simplified by putting 1 over. 1 over the series simplify capacitor and resistor. Right? Exact opposite of resistors happens in capacitors. So therefore, equivalent here is for C1 and C2, we can simplify this way. 1 over C equals 1 over C1 plus 1 over C2. Right? So 1 over C equals 1 over C1, 2D over epsilon naught A plus C2, 2D over K epsilon naught A. Right? Simplify. This is, we can take this out. 2D over epsilon naught A out. Then 1 plus 1 over K. 1 plus 1 over K. Right? Then 1 over C equals 2D epsilon naught A K plus 1. Which means C equals C equals C C1 C2 C so C is K epsilon naught A over 2D times K plus 1. Right? That is C. There is more simplification remaining. More simplification remaining. Now, this resultant here and this resultant, this equivalent here and C3 are parallel because they are connected between same points, same plates. Therefore, C and C3 are parallel. So, equivalent is C final is, let's say C equivalent is parallel capacitors are added just as series resistors. මංගල opposite එක තමයි වෙන්නේ. Then C plus C3. C plus C3. C equals C එතකොට අරග K epsilon naught T over 2D K plus 1 plus C3 epsilon naught T over 4D. Right. Now common denominator should be 4D times K plus 1. 4D times K plus 1. Then here we have 2D. This should be multiplied with 2. This becomes 2K epsilon naught T plus epsilon naught T. Now we can take epsilon naught T out. Right? Take epsilon naught T out, which means 2K plus 1 over 4D K plus 1. See? Local simplification එකක් තියෙනවා. Local simplification එකක්. Answer 4. So 45 answer 4. Simplify කරන්න ඕනේ. මේක local simplification එකක් තියෙනවා. Right? Take down. Right? Parallel plate capacitors and capacitor combinations. So this is a question of those two. Right? Take it down. Take down. Right? Next. 46. The graph that shows the variation of V out with RB when the RB of the circuit in the figure increases from 0 to very high value. Right. So first let's check the very high value. If RB is very high, which means RB goes to infinity. Very high in the sense that is infinity. Other values very high infinity. So which means RB goes to infinity. Right? RB goes to infinity. If RB is infinity, there's no current flows through capacitor, through transistor. Capacitor, there's no current flows through transistor. right? If RB is infinity, IB becomes 0. See, when RB goes to infinity, IB becomes 0. When IB equals 0, therefore, IB equals, IC equals, IE equals 0, right? Now, if currents are 0, VCC is going to be equal to V out. Therefore, VCC equals V out. Therefore, VCC equals V out, right? So, all 3, 4, 5 are wrong because VC should be at V out. VC should be at V out. And when R is 0, there's a current flow. And then when R increases, it decreases gradually. Right? Answer is 1. 46, answer 1. So 46, answer 1. 47. Okay, see, an ununiform rod, ununiform bar is kept horizontal on two vertical metal posts, P and Q, having same dimensions. Okay, P and Q have same dimensions. The Young's modulus of P and Q are Y1 and Y2. Y1 and Y2. Right? Respectively, the horizontal distance from P to the center of gravity of the bar is. Right. So let's assume center of gravity of the bar is somewhere here. Right? Let's assume that is somewhere here. G. And this is on rest on these two. Let's say reactions are R1 and R2. Let's say reactions are R1 and R2. If this is R1 on this column also there is R1, on this column also there is R2. Right? So we know from elasticity F over A equals Young's modulus. F over A equals Y into E over L. Right? Now when this is horizontal, their extensions or compressions should be same. If there is horizontal, it says kept horizontal. If they are horizontal, always compressions are same. So knowing that, apply this. For first one, if can R1 over A, same Y1 E over L, right? And for the next one, it will be R2 over A. R2 over A equals Y2 E over L, right? Now, we can divide these two. Right? A to A cancels. Then R1 over R2 equals E over L to E over L also cancels. Y1 over Y2. Right? Okay. Having this in hand, if we need a distance, we have to write a force moment. Right? Distance is going to be momentarily. Let's consider this as X. Right? And I'm going to consider force moment around G. Right? About G, these two force moments should be same. About G. Counterclockwise is from R2. Then there is R2 times total like the L. That is marked there. L minus X. Then R1 times X. Right? See, now for R1, I can plug. For R1, we can plug Y1 R2 or Y2. R2 plug R1 plug. Then R2 times L minus X equals, for R1 we can write Y1 R2 over Y2 X. R2 to R2 cancels. Now a simplification remains. Then this is Y2 times L minus X equals Y1 X. This is Y2L minus Y2X equals Y1X. So Y2L equals, take X out from other side, Y1 plus Y2. X equals Y2L over Y1 plus Y2. Y2L over Y1 plus Y2. Y2L over Y1 plus 2. For 47, answer 2. Right? Another good calculation. Another good calculation. Take down. Take down. Right? Take it down quickly because I need to erase the board. 48. 48. IV characteristics curve of diode D in the circuit is shown below. Which means one identification, one data that you can get is its voltage barrier is 1 volt. Its voltage barrier is 1 volt, right? And about the Zener diode, in the diagram it's given as 3 volts, which means Zener voltage is 3 volts, right? The voltage barrier VB of D is 1 volt and Vz of Zener diode is 3 volts. That is given. The best graph represents the variation of potential difference V naught across the resistor R naught. V naught across the resistor R naught, right? When the voltage is increasing is, right? First thing is, look at here, the circuit. This is a Zener diode. And here one battery is given E naught, ne? E. One battery is given E, right? Now, voltage barrier here is 1 volt and this is 3 volts, right? When the voltage barrier is exceeded only, diode D will be forward biased. And if the Zener voltage is satisfied only, Zener diode is reverse biased. Otherwise, Zener diode is inactive. Otherwise, Zener diode doesn't work, it is inactive. So, which means minimum, there should be a voltage of 4 volts here to satisfy these two. So, minimum 4 volts. Until 4, there is no current in the circuit, right? When E is less than 4 volts, right? 4 in the addition again, 1 and 3. When E is less than 4, I equals 0. There is no current flow in the circuit, right? There is no current flow. The answer is 4, right? You're right. Answer is make answer. There is no current flow until 4. Then thereafter current flows. Because this will be forward bias, this will be reverse bias. Then current flows. Answer is 4. 48. Answer 4. 49. 49. A large number of equal charges, each having charge q, lie on a line at a distances of 1 meter, 2 meters, 4 meters, 8 meters, etc. Dot dot from point P. Electric field intensity at point P would be right. Something like this. Now a series is going to come. Another popular pattern from point P. So they are like this 1, 2, 3, 4. Likewise, it's there. Right. Now, if I write electric field intensity, see, if I write electric field intensity, we know equation of electric field intensity is what's the theory basic equation? Electric field intensity due to a point charge is given by 1 over 45 epsilon naught. 1 over 45 epsilon naught q over r squared. This is the electric field intensity at distance r due to a point charge q. Due to a point charge q. This is the electric field intensity. This is the theory. Now we are going to apply this. We are going to apply this here. Right? Then E is given by, right? Now 1 over 4 epsilon naught is common for all. Take it out. 1 over 4 epsilon naught is common for all. And each one having charge q. That is also common. Take it out. Q is also common. Take it out. And inside brackets, 1 over r squared remains. For first one, 1 meter. For second one, 2 meters. Then 4 meters. Likewise, it goes. Right? Then here 1 over 1 squared. And this is 1 over 2 squared. 1 over 4 squared. 1 over 8 squared. And it goes like this. Right? And it goes. Then right. Addition of this series should be determined. Yeah, let's see. Now this is a geometric series of half. Is that clear? This is a geometric series of half. That's a geometric series of half. Then how can we get the addition of a geometric series? Addition of a geometric series is Sn equals 1 minus r over 1 minus r to the power n. Addition of geometric series up to infinity now. N over 1 minus r. Yeah, that is correct. But the thing is, the addition of geometric series is not here in physics. So therefore, I will give that as a data. Right? I think it's not printed here. One addition එක data එකක් විදිහට දෙන්න. Give me a minute. I'll check. A over 1 minus r for the infinite series. Okay. I'll give that as a data. That data is missing in the question. So in the question, mention that as within brackets, mention this data. Addition of infinite number of terms in a geometric series is given by addition of infinite number of terms in a geometric series is given by S equals A over 1 minus R. S equals A over 1 minus R. This is a data, it should be given. This is a data, it should be given. Right? So that's a typing error in that question that is missing. Right? Otherwise, it should be given. Right. Where A is first term, and R common difference. And R common ratio. A is first term and R common ratio. Right. Now we can find this out. See, apply this equation is A is half. Sorry, A is half. May geometric series again only half. A is half. Right. Over 1 minus R किया 1 over 2 squared, 1 over 4 squared. Then 4 16 1 over 4 1 over 4 1 over 4. Right? So S equals 1 over 2 over measuring in 3 over 4. So S equals 3 here and 4 and 2 cancels ne 2 over 3 ke leno ne. Correct? Yeah, 2 over 3. Now plug that here. Now it's done. Sorry. First term is 1. Ne? Yeah, it's correct. First term is 1. Yeah. First term is 1. Wait. Yeah. First term is 1. Yeah, first term is 1. 1, 1. We're measuring the 4 over 3. Ne? 4 over 3. So S is 4 over 3. Right. So plug that here. 1 over 4 5 epsilon naught. And for the addition here, times Q, whether Q times Q. When may part 4 over 3. Right? 4 to 4 cancels. Equals Q over 3 epsilon naught 5. Answer is 3 epsilon naught 5. Answer 2. 49. Answer 2. Right. So this should be given as a data. This is the addition of an infinite geometric series. $50. The conducting loop in the figure rotates at a constant angular velocity around its axis A. There are two uniform magnetic fields which are perpendicular to the plane of rotation of loop according to the figure. Variation of induced current I with time is well represented by. Right. This is the point. E is given by E is minus d phi over dt, which means E is given by minus delta band over T. Right? Now, when the loop enters the magnetic field, area changes. So therefore, this is what I'm going to check. This is what we are going to check. E is proportional to delta A per unit time. Right? E is proportional to delta A per unit time. Right? And this side is cross. Whereas this side is dot. Right? And the loop is here. Right. Okay, the loop is here. Right. Okay, now have to check. Now, when this enters this field, so likewise, same amount of delta A per time intersects me. Because that's a uniform, it rotates with the constant angular velocity. It says it is uniform angular velocity, a constant angular velocity. So same angle rotates, same angular displacement is therefore each second. So therefore, second to second, the same area cancels, same area intersects. When same area intersects, according to this, E will be constant. When same area intersects, E is constant. Hari, E constant values විතරක් බලන්න. 1 එක තියෙනවා, 3 එක තියෙනවා. අනිත් ඒවාගේ vary වෙලානේ. අනිත් answers තුන නැහැ. Now I have the try between 1 and 3. Right? And when this enters, now we have to check these directions. Directions check කරන්න ඕනේ. When this enters, this leaves. When this one enters the field, the other one leaves the field. Right? Now, here, if I need to determine the direction of current, there's a method. The method is Lenz's law. Lenz's law. In Lenz's law, what it says is, always the current flow satisfies the opposite action which causes this. Right? Opposite action. Now here, the action is, see, at this point, action is increasing B because it enters the magnetic field. So opposite action is decreasing B. To satisfy the decreasing B, current exerts to check current flows, to check the direction of current, apply right hand rule. Right? Now, this is a dot field. Then that dot field should be minimized. Then there should be a cross field. So direction of current is, to satisfy a cross field here, direction of current is this. Let's say I. Right? And here, cross, this leaves. Here the action is decreasing B. So opposite action is increasing B. To increase a cross field, another cross current should be given. Another cross current again. See, now these current flows are same direction, same cyclical direction. Same cyclical direction means they are adding up. They are adding. Now, if I have checked the variation, when it enters, when it leaves, it will be the exact opposite. Right? Enter වෙද්දි වෙන එකේ opposite එක තමයි leave කරද්දි කොහොමත් වෙන්නේ. Right? Enter වෙද්දි එක opposite එක leave වෙද්දි කොහොමත් වෙනවා. ඒ හින්දා it cannot be 3 because the opposite happens when it leaves, it exists from the field. When it enters, in this direction current flows. When it exists, the opposite direction current flows. Nothing to check there because that is what happens always. Therefore, answer is 1. For 50, answer 1. For 50, answer 1. Right. Answer 1. Okay. So that's the end of all 50 questions, the discussion of 50 questions. Right? Yeah, it's 10:30 now. And I didn't want to stop the discussion in between, and I discussed all 50 and finished it off, right? Yeah, it's 10:30. That's fine. Now you are just 8 weeks ahead of the exam, right? 8 weeks ahead of the exam, right? Okay, and yeah, now this was the part 1 of paper 4, and by Wednesday or by Thursday, as usual, you will get the part 2, right? And now, as I have been telling, the academic session should be conducted, but the only concern I have is the less participation of students for the live classes. So therefore, if there's a less participation in live classes, now if I conduct the academic session also, if you are not participating it, if you are not joining it, right, there's no point of conducting the academic session. Right now, in the past paper class also, I noticed that now I started the past paper discussions on Wednesdays, and only few students were on the live class from this batch, right? From your batch. So that's the concern I have. Yeah, we'll see if your participation is there. It will take like 1 to 1.5 hours, maximum 2 hours for the academic session, right? So it's also easier for me to conduct it now in these coming weeks other than keeping it to the next month. Next month එකට තියාගෙන වැඩ උත් නැහැ. Right? මේ month එකේ කරනවා නම් කරන්න ඕනේ. Right? And I'm always into do that. The thing is the less participation. Right? So in this class and the past paper class also. Right? Most of you are watching the recording. Right? Due to several reasons. But for the academic session, if I'm conducting the academic session, I need your participation. That's the thing. Yeah, let's see. I'll drop a message in the group as well to take a vote, right? And with the votes, let's see whether how the participation is going to be, and if the participation is enough, we'll conduct the academic session. I'll let you know a date, right? Okay then. And part 2 of this paper will be sent to you on Thursday, and do it as a time paper. And yes, and other than that, most probably I'll be putting another homework paper this week onwards to the group, right? මම කෙලින්ම group එකට දාන්න homework paper එකක්. ඒ homework paper එකත් නිකන් ඉන්න ගමන් try කරන්න. That is something in addition to the paper we discuss here, right? I'll send you another homework paper, right? So do everything, and if you have questions, ask them and clarify. And as I told you, if you have anything to clarify, use our paper class group as a platform to discuss questions, discuss subject matters. I'm totally fine. Either me or any other one can answer your questions. If you didn't get an answer for a particular question, feel free to put that question to the group, asking is there anyone who got the answer for this question, something like that. Then if there is someone, he or she would reply. So likewise, you can use that as a platform to like subject matters, question discussions and subject matters, right? Because I need all of you to go through as a batch, right? As a whole, as a group, right? That's the thing. And always sharing knowledge is a nice attitude, and it's a nice quality a human being should have, sharing knowledge and helping each other. So therefore, yeah, please feel free to use that group for all your discussions as well. Right now we are in last 2 months, exactly 8 weeks, last 2 months, right? So feel free to use it, right? Because now all of you are working towards a common goal of A levels in 25, right? So therefore, even if you get one MCQ, if you got something out, one MCQ, which means you are going to acquire 1 mark. So likewise, if all of you share your knowledge, all of you can go through this together, right? Right? Therefore, don't have individual competitions, just go through as a batch, as a whole, as a group, right? Okay, so feel free to use it for all your discussions. That's totally fine, right? And actually, I'm happy to see if you are discussing something there, because then I know you are actively engaging and you are doing something, you are putting some effort, right? Okay, yeah. So for a week, this week onwards, most probably you will get 2 papers as one homework and one for the discussion here. Yeah, then that will be the plan for next 8 weeks, most probably, right? So let's see if there's any change. I'll let you know through the group. And about the academic session, I'll get a vote. Let's see after the vote. Okay then, that's it for today's session. I'll wind up the session here. Any questions? Any questions? Any questions? So is it all good? Any questions? No. Okay then. Then we'll wind up the session here. See you all in the next class. Stay safe and work hard, study hard. Goodbye and good night.